Hi Gunnar, welcome back.
Hey Adam, thanks again for having me. I'm very happy to be here.
So today is a ghost show. So we had already two phantom problems here.
Everything will be good.
Yeah. What is kcktl?
kcktl, right. So I'm so glad you asked, Adam. So yeah. kcktl, it's a surprise. It's a command line client for Kafka Connect. So you are a user of Kafka Connect, right? So you need to interact usually with Kafka Connect with the REST API. So if you want to register a connector or start a connector, stop a connector, you do all those REST calls, or you use something like Strimzy, a Kubernetes operator, if you are in Kubernetes. But yeah, so if you are using this REST API, I figured, well, that's really cumbersome. It's error prone to use. And this is what kcktl seeks to address. So it's a command line client for Kafka Connect, and it comes with all the commands you would need for setting up connectors, pausing them, getting the logs, seeing just the connector status, all those kinds of things. And it comes with auto-completion. That's very nice. So if you are on the CLI and you do a tab, it will display the matching commands, will display the matching connector names. It will even fetch the information dynamically. So it gives you a very easy to use interaction experience with Kafka Connect.
Okay, so what you did, you wrapped the REST endpoints, the REST interfaces from Kafka Connect, right?
Exactly right. So it's a quarkus-based application, by the way. It takes the Kafka Connect REST APIs, and then this actually also allows for some nice usability improvements because, well, over time, new APIs were added to the Kafka Connect REST API, right? So for instance, in 3.0, I believe they added an API which lets you get the information or the logs, I'm not quite sure, of multiple connectors at once, whereas in earlier versions, you would have to iterate and you would have to run multiple REST calls to do the same. And now all those kind of things we can, of course, take care of. And then it's the same command in kcktl, no matter what the underlying REST API version is.
And you said you used quarkus. What you used for the REST communication? MP REST client?
Yes, exactly. So it's I believe, to be honest, but yeah, it should be the microprofile REST client, yes.
Interesting, because my first choice would be JDK 11 HTTP client.
Okay, yes, I guess I could do that. Probably it doesn't matter. To be honest, we don't have many specific requirements around that REST API. We need to do authentication. That works, I guess. I could also do that with the OpenJDK client. It was just what was offered to me in the Quarkus documentation, so that's what I went with.
So the kcktl is just, I would say, it is a proper Quarkus application with dependency injection involved. So
yes, exactly. So it uses this other framework called picocli, which is everything but Pico, but it's a very powerful library and API for implementing CLI applications. And yes, so there we get then, for instance, I don't know, dependencies injected into those commands, things like a context, stuff like that. So yes, it works with dependency injection.
So interesting, right? This is like almost like a server application, but it's command line. I mean, you have dependency injection, like an MP REST client, and Quarkus, and yeah.
Right. In terms of the architecture, yeah, maybe in a way. And then, of course, it's compiled down into a native binary via graalvm, right? So that's what you want to have. In particular, if you do this tab completion and it needs to invoke the actual command to get, for instance, the connector names. So for that, we need to be very, very fast. Otherwise, it would be a sluggish experience. And well, compiling into a native binary, we have that. So you have this instantaneous feedback, and it's a very nice experience, I would say, to use it.
How you use Quarkus? So, I mean, this is not the default setup, because it would just start and run the entire time, right? So it is like you started Quarkus with the main method, right? By yourself.
Yes, we do that, but I don't think you even would have to do that because there is this Quarkus extension for picocli, which lets you build a command line client with Quarkus. So that's takes care then of taking the main method and not starting the HTTP server and this kind of thing. But yes, we do have a main method because we want to customize some sort of error handlers and stuff like that in our application. But you wouldn't have to do it.
Yeah, this is exactly what I do, actually. I start Quarkus with the main method and then run the server. And I didn't use the picocli, I just Quarkus plain, but it also worked well. So, and this is, it behaves like, I would say, server-side application because dependency injection, everything works as you like. but
Right.
that doesn't start, the HTTP endpoint.
Exactly.
It is not a server anymore.
And if you use this extension, you also have a better editing experience, I would say, because this quarkus dev mode, right? And this also supports building CLI applications. So what you then, for instance, can do, you start it in dev mode, then you enter your command. So I don't know, in my case, I would do get connectors, or get, restart task, whatever I would like to work on. And then, it will run that command once for me. I do a code change and I just need to hit enter and it would run the same command again for me. Or I could run another command. But
that's interesting. This is our two true benefits. So if you use the picocli extension and didn't thought about that, then you can it would run in the development loop all the time, and I can edit. This is actually great.
Exactly right. So you have a really good dev experience, I would say. You get very quick feedback, and just as fun to build applications that way, I would say. And the thing is, so usually, as you know, we spoke about last time, I work on Debezium most of the times, right? And I'm not a user of Debezium. I mean, I don't have the need I don't deploy Kafka and Kafka Connect myself, right? Whereas here with kcktl, I am actually the user of the tool because, I want to test Debezium and I want to, build demos with Connect and so on. So I can use kcktl myself. And that is just a nice, experience for me because, I see, okay, there's this feature which I would like to have, or there's this usability glitch, so let me fix it. And it's just an enjoyable experience to build something which I actually can use myself.
So this is actually what it means for me, that kcktl is more usable and a higher quality than Debezium, right? Because
I did not say that. No, I would not say that. But speaking of that, what we do want to do is we may actually add some Debezium specific functionality even to kcktl. So for instance, if you are using the MySQL connector in Debezium, there is this history topic, right, which takes care of, or which stores the schema history. And now this schema history, this can grow a lot. And then if you restart the connector, this can take quite some time because it needs to reread the entire history. And maybe there's old entries which we don't even care about any longer. So there's the idea to have some sort of compaction functionality for the schema history, and this then could again be another feature in kcktl, and it would expose that Debezium specific functionality to you.
How you tackle the REST thing? So is it like you are using not reflection, but you are exploring the REST interface, or all the paths are hard coded? So how to.
Yes, it's everything is hard coded. I mean, the REST API and Connect is not huge. So yes, we have there's the way it works. You define interface with the methods. You need to annotate them a little bit. You define the return types or the parameters, so to match the API, and that's what we go with.
Okay, so pragmatic. And because I think also about CLI a lot, so I write a lot CLI client for myself for various tasks. And actually, if you're writing CLI clients which are extensible,
yes.
JPMS could make sense, right?
Oh, yes. I mean, that's a very interesting question. So far, we did not have that need. All the commands, they are built into kcktl itself. But yes, so if you wanted to have some sort of plugin functionality, yes, then you looking at JPMS and maybe module layers, actually, this would be a very interesting capability.
Because I thought, so what you usually need, like the code completion, code completion. Is it code completion in CLI, not code completion, command completion maybe?
I call it tab completion.
Tab completion. The tab completion and whatever functionality, so it could be a core, and
right.
the JPMS modules could bring their own functionality. So the core could ask, give me your completions or whatever, and then call as a command pattern.
Right.
So I thought about this a lot because in my microservice cloud or server-side world, there's no room for JPMS. I mean, it's not needed. But for CLI, it should actually work perfectly, right?
Yes, I mean, the thing to keep in mind is, so right now, I don't think JPMS is really supported in GraalVM native binaries, right? Which means your CLI tool will be a bit slower to start up, and really for CLI, every millisecond matters, right? So if it takes, 300 milliseconds to start, you will notice this, and that could be a problem.
Yeah, right. What's also different in your case is that every command starts the CLI again, right?
Exactly right. So that you
So
install
that's
it
the
all
difference.
the time. Yeah.
Yeah, because if you run it once, no one cares because it's fast enough. So what I usually did, if I was lazy, I just created superjar or überjar in quarkus, and this was good enough. And then because and then wrap it in a shell, and it was good because it starts in half a second and no one cares. And but
so to be no, sorry, go ahead.
And in your case, it's different because or wait a sec. kcktl runs all the time, right? Because if you got code completion, tab completion inside kcktl, so it already runs.
Oh, no, that's the thing. So if you do tab completion, there's two ways how it can happen. So there's a completion script, and all the commands and all the command flags, they are obtained from that completion flag, from that completion script. So we don't have any interaction. But then if we do a completion, sometimes we need to get, let's say, the names of the connectors. So there's a command called kcktl describe connector, and if you do tab at that point in time, it should suggest you the connector names which actually exist. And this is why we need to start that fast, because when we do a tab completion at that point in time, then it will start kcktl, and it will invoke like a special command which you usually cannot invoke by yourself to just give the completion which tells you about the existing connectors.
Yeah, you're right. So you need, GraalVM for sure. Otherwise, it would be too sluggish. Okay.
Exactly right. So this would be too slow. But still, I think you could build something extensible. I mean, you could think about having multiple binaries, right? And think about using, this Unix domain socket support, which recently got added in Java.
Yeah, but this is overkill. With JPMS would be really a killer use case for that.
Yeah, maybe. Yeah.
I'm searching for, because it's one of the questions now whether I'm using JPMS, and right now I have to say no because I'm not using it. But for that it could be beneficial. But you're right. If you do it right with GraalVM, then it's problematic.
Yeah. And we built kcktl for all the three big platforms. So for Windows, for Linux and macOS. And Andres Almire, you know him, right? Yeah. He did a great job with his JReleaser project to help us automating all that. So whenever we push a commit to the kcktl repo, it will build preview binaries for all the three platforms. And you can get the latest binaries like the next minute from GitHub. And it will also be available in SDKman. Maybe I even get to it over the weekend to set that up.
Nice.
And then we will have, an easy way to install it over SDKman.
But wasn't the deal that you had to rewrite the case in Groovy then? If Andres...
If Andres works?
Yeah.
You could think that. No, so far he didn't make a push for that yet.
There was a defined print, I only release in Groovy projects, so this was like...
Yeah, no, he has been so helpful. I'm really very thankful for all his help with the release stuff. It's amazing.
Mm-hmm. So it seems like a command client done right, because this is a lot to do actually what you did. So you use quarkus with picocli in order to have the GraalVM support, of course, for command, and nice arguments parsing and dev mode in quarkus. Then, of course, the REST endpoints were hard-coded. There are not a lot of them. Perfect. But what happens behind the scenes is you get the tab completion. So what you're doing, you are invoking kcktl again to get connector names, and then it has to be fast, right?
Exactly right. Yes. And for me, it's a very nice validation also that you can build modern CLIs using Java, right? I mean, there always was this sort of prejudice. You couldn't do it, but this really has changed, right? So now with this tool chain of Quarkus, GraalVM, all those kind of things, you get to build CLIs in Java, which give you a very good user experience. And I mean, the binary, it's not super small. I believe it's like 40 megabytes or something. So yes, it would probably be a bit smaller if you were to use Golang or Rust or whatever. But then, I mean, who cares, right? So you.
It's like iPhone picture, right? So like a single picture is your API.
Yeah. So who cares, right?
Yeah.
So this doesn't matter. And you have all those nice APIs which we are familiar with. So I believe that's a very valid option for building command line applications.
Absolutely. And I don't know whether you know Python or other scripting language. If you compare this, what you did with Java to, are you familiar with Python?
A little bit, not that much.
No, or something else. I'm also just Java and JavaScript, but would be interesting to see, compare your code with Python code, let's say.
Yeah. Yeah, I guess. But in terms of the code, to be honest, it's not that complex.
I know that. I like Java, but I hear all the time Python is easier. I don't believe that. But it would be interesting, if you would know Python, you could say, okay, this was the problem with Java. But as you said, now we have a native solution to and yeah.
Right.
It's nice, yeah. Regarding JavaScript, I mentioned JavaScript. What I actually did as a plugin model, GraalVM supports JavaScript.
Oh, yeah, okay.
And what I did is I loaded dynamically the JavaScript code because some things are easier. So I did, templates or string manipulation, stuff like that. I did in JavaScript, and then you can cross-compile it to GraalVM anyway, to a native image, or to GraalVM to a native image. So this could be an option that you can actually load a dynamic language and use it as an extension point.
Just to be careful, you don't run into any issues like with Log4j, where you take code by the user and you execute, right? So that's
Log4j. With Log4j, we have the plugins, right? So if you run Log4j in kcktl, you could actually extend at runtime everything.
Yes, and I could give ownership over my system to everybody else, probably.
To Casey Brutal, maybe, not Kettle.
Exactly. Yeah.
No, and not use a script rather than something which just simplification of the thing. But this is really useful, and this is really easy with Graal. You're just adding additional library, and then you can from Java talk to JavaScript. And what you can also do, you can implement a Java interface with JavaScript.
Mm-hmm. And is it then still just in time compiled? I suppose
to native image, yeah, it works.
Okay. Interesting. Yeah, I need to check that out.
Mm-hmm. Exactly. So this sounds great. I mean, this is super useful. It has to be super popular as well, right?
Well, so it's growing, right? So there is a small community, I would say, which has formed around it. So several people have contributed. So, for instance, somebody is working on displaying the connector offsets. So that's something which comes up all the time. People would like to see the source offsets of a connector like Debezium, or maybe reset the source offset of such a connector. And this is also something which we will add. And yes, it's not me who implements it, but it's people from the community. And yes, I have seen it. People use it in demos. Somebody wrote an article around it. So yes, I would say there's some uptick around it.
So already 125 stars, which is not bad. This is, and the on GitHub is kcctl.
Right.
Which is a great name. And so you have actually a good feeling for useful libraries, I have to say. It's nice.
Cool. Great. That's, I'm happy to hear. I mean, this really was to scratch my own itch. When I test Debezium connectors or I build demos, I always had to work with curl or HTTP. And well, now as I have that, CLI, I just feel, okay, it's so much easier and, it's just much more enjoyable. So that's why I built it.
Mm-hmm. Okay. What's your next pet project? Because, I mean, kcctl is not enough.
Right. There's another thing, and this is in relation to the JDK flight recorder.
Yes.
So I'm a big fan of that, and it gives you all the deep insight into your JVM metrics, right? Like what is its garbage collection doing? What's the object allocations, class loading, IO, and so on. So you can examine all those performance characteristics using JDK flight recorder, or JFR for short. And one of the things I've been built adjacent to that is a project called JfrUnit. Mm-hmm. And JfrUnit, essentially, it's an extension to JUnit 5, which lets you run assertions on JFR events. And the idea is to use those JFR events and the assertions you do on those JFR events to identify potential performance regressions in your application. So let's say there's a metric like object or memory allocations, right? So and this also, by the way, got substantially improved recently in Java 16, where you can track continuously how much memory your application allocates. And now the idea is, so your application, it has specific use cases, right? Let's say there's one use case for placing a new purchase order in your e-commerce application. And the idea is, well, you keep track of how much memory this use case allocates, And now if there's a regression, so maybe suddenly it allocates 10 times as much memory for the same use case, then this could be an indicator that something is going wrong. Or let's say it does suddenly 10 times more I/O with the database than it used to do before. So this is something to look into. Maybe you're, running way more SQL statements and so on. And that's exactly the idea. So you can track those metrics, and then you can use JfrUnit to run assertions against those metrics, and your tests would fail if you had such a regression. So if there was suddenly much more I/O than before.
Super useful. What I'm usually doing very similar, but differently. So what we have is system tests, and what the system tests are doing, like a black box test for microservices. So we have a microservice, and it exposes REST interface, and we have another module, complete different, isolated different module. In Quarkus, there are two Quarkus projects. One is the main service project, and the other one with microprofile REST client, like the kcktl project, right, which accesses the other remotely. So, and we are performing the system tests, and then some critical path you can easily test with executors and starting something in a sequence and see how it goes. And then what we do, we are connect to the system again using microprofile metrics. And then you can fetch, the data, but this is basic data. It's not comparable with JFR. But you can at least see whether, we have the threshold is okay. Is there any regression? Does it looks right? So you get at least an idea how the system is working, whether it is working at all.
Yeah.
And in yours, it's even finer grained, because what you can do is you can look into the JVM and see what happens.
Exactly right. And so the reason for building that was, well, I mean, we do have regression tests. I would say it's a very stable and established practice for functional aspects, right? So you have unit tests and so on. And if a functional regression is there, you will find out about it. Or I would say you don't follow good development practices. But it's a bit different for performance regressions, because setting up automated performance tests, that's really tricky. The reason is it depends on the specific hardware and the specific environment, right? So let's say you measure an absolute metric like what's the latency of my request or what's the throughput. This, of course, depends on the specific execution environment or how much load there is. So maybe you run those tests on a CLI server. If there's other tests which also produce much load, they run at the same time, then your own throughput will be reduced. So you just don't have a means of having those tests in a stable way. And this is exactly why JfrUnit or the testing approach of JfrUnit is not to assert those absolute performance metrics, but rather what we call proxy metrics, like allocations, like I/O, or maybe like the SQL statements which my application executed. And then regressions in those proxy metrics, they are essentially an indicator that also there is an actual performance regression going on.
Yeah, and what's nice about that, looking right now at the source code, of course, you introduce some annotations. And
yes, right.
So this is like a test runner, I assume. This is the first one, because it is JFR event test, and I assume this is the test runner. And then you get access to the test class, so you are able to introduce interesting annotations like enable event. And,
exactly right.
Yeah, and so it means, and how you connect, so it has to be, of course, enabled, and you have to have a connection to the JVM running, right?
So yes, right. So first of all, on those annotations, so you use those to specify what are the events or the event types you are interested in for a particular test. And then what happens is that the JfrUnit extension will start a recording for those event types. And then since, I don't know, Java 14, I believe, there's this event streaming API. So this means you can get a real-time stream of the JFR events out of your JVM in process or even out of process. And that's what we use. So it does start the recording. It subscribes to this event stream essentially. And then once the recording or the test has finished, or the code under test has finished, we can then run those assertions and examine what events actually are there. So that's why if you look at the code, there's this await events barrier. This is there to make sure, okay, everything before this was my code under test. And as all this is asynchronously, we need to just make sure we have captured all the events, and then you can run assertions against those.
How you know whether they are your events, because it could be there are some events before and some events after, right?
Yes, so there is a specific event which JfrUnit emits itself. So this tells us the boundaries of the execution, essentially. So we discard anything after this, JfrUnit.
This is smart.
Event.
So you are starting the test and now I'm starting the test and you are waiting for your own event and then this is perfect. So this is actually a nice solution because I thought how you solve the problem. Since JDK 14, I don't know how long it is already ago. Yeah, I always wanted to stream the JFR events into Kafka.
Yes,
for fun. This was like I will do this. Yeah, sometime I will have to do this, and then I wanted to use Kafka streams to analyze for fun. What happens there.
Yes, okay, that's great. Because that's exactly what. So I want to do some streaming analytics on JFR events. So I would like to have something like Kafka streams.
Exactly.
So I can do windowed queries and so on, but maybe not necessarily going through Kafka. I mean, ideally, I could do this in a library within Java itself, right?
Sure. But with Kafka, we could use quarkus and have more fun because usually, this would be like side project. Let's see how it goes because you get lots of events for free.
Yeah.
And usually, if you would like to test something, you don't have events.
Right.
And I say, okay, instead of I will. This will be some useful experimentation.
Definitely, I would love to do that. Maybe we can team up on it. I don't know. I think that would be
we
great.
Need a mascot first, like the J. What start with J? Something with dinosaur or alligator.
Because there's so many ideas around it. So I have also spoken to our performance engineers. So we have a very established and a very mature performance testing team here at Red Hat, and they make sure all the quarkus and the Hibernate performance and everything it's up to date. And they are super interested in that because they could use this, for instance, to identify performance regressions. Let's say also in Hibernate or M itself, right? And so I have had some interesting discussions with them. One of the things we would like to add, for instance, would be keeping track of historical trends and historical development. So let's say you have some test and I don't know, it does 1 kilobyte of database IO today. Now tomorrow it does 1 kilobyte and 10 bytes more, right? So that by itself is not a big thing. But so let's say maybe this happens every day. So very slowly over time, you have more and more IO. But if you look at each change itself, it's not noticeable. But if you look at the results from half a year ago and compare them to the results from today, maybe then you would say, okay, that actually is a relevant regression and that's something we need to look into. And that's some of the things we would like to have, some sort of repository where you could gather the data and then you could also do historical trends analysis around the JFR events.
What you should have adaptive assertions. Like, you say we should not consume more than 10% of the CPU, and then you consumed 5. So it's okay. This is the assertion is way too how to call it.
Oh yeah, right.
How to lose? Exactly. Then you can adjust it 5% down.
Exactly.
This could work actually.
Yes, exactly. That's another motivation for this historical trend analysis. As you say, if you have improvements right now with the assertions, you wouldn't know about them, right? And so if you are doing an improvement and then it's getting worse again, you wouldn't necessarily find out. And that's why having this historical analysis would be really cool. But then as you said, it's a side project, so I just am able to spend so much time on it. But I think it's a very powerful testing approach, actually.
Yeah, and JFR is actually great. I had in all the firefighting projects, the JFR was super useful because what we can also do, not stream in real time. You can request the file afterwards. They can record, you get the file, and you can analyze the entire stack without being connected to the JVM.
Exactly.
It's also super useful.
Yes, and I should say that. So that's also used here. So if you run such a test with JfrUnit, it will also persist a recording file. And let's say now you have a test failure, an assertion failure, then you can load this JFR recording into mission control, and you can examine the entire thing, and you can, for instance, see then where this regression is happening, right? So let's say you suddenly have an assertion failure and there is much more allocations, much more IO or whatever. You could see quite easily in mission control where this is coming from. So you would be pointed to the places in the code which are responsible for such a regression.
Oh, this is also smart. So what you are saying is that if you run your test, it's also recorded with the JFR.
Exactly right.
And then you can analyze your test afterwards, which is perfect because the test is actually the client which drives the application, right?
Exactly right. So yes, it makes really use of those capabilities, right? For streaming, so just to implement the assertions in the test, but then you also have the persistent recording for offline analysis.
Yeah, great. So we have also the project Larry.
Right. Let's talk about Larry in a second, but there's one more thing which I wanted to mention here on JFrUnit, and this is there's another project which is called JMC Agent. I'm not sure whether you have heard about that one. So, as you said, there is lots of JFR events built into the JVM itself, like more than 150 event types. Mm-hmm. You can create your own custom events. Mm-hmm. So let's say you have something specific to your application. You could create your own JFR event types. Mm-hmm. But then also with this JMC agent, what you can do is you can instrument existing code to emit JFR events on your behalf. And just yesterday, I wrote a blog post, or I published a blog post for the Java Advanced blog, where I show you how to use this for analyzing the SQL statements of your application. So what it does is it instruments essentially Hibernate ORM, and it instruments the connection pool, agrol, and then whenever there's a SQL statement, it will emit a JFR event. And then again, you can use JFrUnit to run assertions against it. And what this allows you, it lets you find out if your test suddenly runs more SQL statements, or it suddenly runs unexpected SQL statements. And then again, you would be very easily, you could very easily find out, let's say you have something like an n+1 select, this kind of stuff. You could find this out in your unit test, actually.
So with that, you could actually even generate unit tests, right? Or at least scaffold unit tests. Because I
guess. Yeah.
Because if you have the information in the events from the application, in the SQL statements, and this is because now we narrow the context. We say, okay, this is now Hibernate specific, and
right.
So you know actually what to test. So you could actually at least scaffold the methods,
right.
and
yes,
say, okay. Yeah.
Yes, exactly. I'm not sure, whether you would want to verify each particular statement. Maybe that is a bit too, fluctuant.
But you could have a threshold, You can automatically say, okay, whatever takes longer than this, then I would generate a test for that.
Exactly right. There's duration. That's a good point. So you can also capture the execution time of statements with that, because what JMC agent allows you to do, it lets you wrap a method, and then it will, the event duration will span the entire invocation time of that method. So that's what I did, for instance, for the execute query method. So I tell it, okay, this is the method you should wrap, and it will start the JFR event at the beginning of the method, and it will commit the JFR event at the end of the method, which then tells you, it will show you in the JFR recording how long did this particular query run actually.
So was it hard to build the JMC agent? So
I should say it's JMC agent. That's not a project I built, right? So that's a project which is part of the JDK mission control umbrella. Yep. So even part of OpenJDK, if you will. And I contribute a few fixes. And so that's a ready-made agent, and then you configure it. So there's an XML-based configuration actually. Mm-hmm. So that's still old school, and with a schema and everything, so pretty good. And you configure it, which are the methods you would like to instrument, and what are the parameters which your or the attributes which your event types should have. So you also can capture, for instance, the parameters of a method invocation, and they will be emitted into.
Okay, so that is so you configure the Java Flight Recorder agent, right? To capture methods, and you probably use some kind of regular expression, similar thing to say, tell these methods are interesting for us.
Yes, well, you need to you need to specify the methods, with the parameter types and names and class type and so on, and yes, then the agent will take care of it and it will emit all those events for you.
Then other way around, right? You could even with your JFR unit generate XML. If you have a test and you say I'm testing this method, and create additional events just for the method, so you could actually do this.
That's an interesting one, I guess. One could think about it. Yeah. Worth exploring, I suppose.
Because now you have the nice annotations with the with methods, and you say I'm really interested in more information about this particular method. So what you usually do in unit tests, you specify the method which has similar name or the same name as the production method. And with annotation, what you could do, you can generate, a small input XML as a help for the JMC agent, and then it will emit specific events just for the method, right?
Yeah, that could work. I mean, what I just find very interesting about this, you have really a powerful stack of all those open source tools, which gives you all that insight, right? And, not long before you would have to buy, commercial APM tools. And now it's part of the JDK or it's, layered projects, and you have a very powerful performance analysis.
I would say the secret of Java Mission Control was the JRocket back then.
Right.
And this was the JVM. And what's interesting with the mission control and JMC, Java Mission Control or Flight Recorder, is that they need the statistics anyway. So they're gathering everything for the optimization of the garbage collector. And if you pick the stats, it doesn't cost anything or not a lot. It doesn't slow down the machine. And if you did it before, the instrumentation was terrible because the bytecode was modified, so it was not usable. So this is actually what makes it usable.
Definitely. I mean, it's really, I would say, meant to be always on, right? And of course, it depends on the amount of events you capture. But really, for instance, you can do object allocation tracking in a continuous basis now because it's very efficient and it costs you less than 1% overhead. So you just can keep this running in production, and maybe you keep your recordings of the last 30 minutes or whatever, so you can analyze them if there's any problems in which show up in your monitoring, for instance. And what many people don't know, all this is open source, right? So whenever I talk to people about Flight Recorder, many people still believe it's a commercial feature, which it used to be, right? You had to unlock it. But since OpenJDK 11, and it's even got backported to 1.8, it's all open source. So you can use all those tools, and yes, it's all there for you.
Yeah, it's great. So we're done with JfrUnit, right?
Yes, I think we are done with JfrUnit.
Okay, because now we have a family of open source project called Modetect.
Exactly right, Modetect. So
it's your secret company, right?
Well, it's my, let's say it's not my. It's a open source community of different projects, which I happen to be a part of, I would say. And the scope, I would say, is, it's related to the module system. It's related to JFR. So like, JVM, Java, low-level related projects, I would say. That's the scope of that community. And yes, so as you were mentioning, Larry, that's something which, again, I actually built together with Andres Almire. So this is taking the Java module system, and in particular, this notion of module layers for building plugin architectures. So as you were asking about plugins in the CLI. So yes, that's what Larry would let do you. Because, so maybe I should take a step back. So if you have the Java module system, so by default, it has a flat module path, right? And it also doesn't make any assumptions about module versioning. So you need to think about yourself. How do you obtain the modules and what are the module versions? And Larry essentially goes a step further because it lets you describe a layered structure of your Java modularized application. So what you do is you specify those layers, and essentially layers, they correspond to class loaders and they provide you with isolation. You specify the contents of those different layers in terms of Maven coordinates, essentially, and then Larry will download those Maven artifacts for the different layers, and it will build a layer graph or layer hierarchy of that application. And now what you also can do is you can point it to plugin directories. So then you just can copy some jar into such a plugin directory, and it will dynamically create a module layer just for that plugin. So which means you can dynamically extend your application. You can add or remove a plugin, and all that in a very dynamic fashion.
So, similar to NetBeans plugin module, right? Because
yes,
you mentioned layers, so it was
yes,
yeah,
right.
really.
So there's some also there's some comparison, of course, to be made in terms to OSGI, I would say, but it's much less feature rich. It's really it's taking this notion of module layers, which is built into the module system, and it makes it just a bit easier to use by means of those layer descriptors, essentially.
Yeah, nobody's perfect. You're even supporting YAML, but you don't have to use it, right? So
right. I think Andres was making a push for it.
Okay, you see, and the next thing would be Larry will support Groovy. So you have to already search, for .groovy files. Are you using Larry for your projects, or you just
no? It's and to be honest, it lost a bit of traction. So I'm not using it. I don't have the need for it right now. But let's say something like Kafka Connect, which also has a plugin architecture, right? This actually could be built, I would say, on top of Larry, because it would be a very solid foundation for that. It would isolate plugins, so you could have, for instance, the same module in different versions, in different layers, and they would not conflict. It would take care of that dynamism if that's what you wanted to. So you could build something like Connect based on Larry, but right now I don't use it myself. I believe Andres, he did some exploration with the JavaFX application where you could add or drop JavaFX controls to a running application, and would then update the view of that client.
You mentioned earlier performance engineer, and I have to think about this the entire time because what immediately came, I worked for a project and there was a performance engineer and his name was Vlad, but he looked like the Terminator. No kidding. He was a young guy, but he was a really strong guy. So really like a Terminator. And and if someone was too slow, he just had he run all the performance tests and did the stats and diagrams. He came to the developers and just told this is too slow. This was what they said. Performance engineer. He was also performance engineer. This was he's a really great guy, and then he wrote also multiple articles. I have to try to find him again. But this was actually a perfect experience because this was really a performance engineer. This was then, he looked like.
And if you were too slow, you were terminated.
Yeah, almost right. So then you had to make it fast, of course, right? So this was the deal, and nice. On regarding JavaScripting, what I actually did before, what I did right now, I had to copy some files with some processing, and I say, okay, what I do, Python or whatever, or shell script, and I just pick Java and ran it as a shell. You can, and it was actually good enough. So it was faster than anything else. You can just copy Java source code to a shell and say this is a Java code and this is executable, and you can run it from a computer, which is interesting actually.
Oh yeah, sure, with the JShell command. But you have heard about JBang as well, right? From Max Anderson.
Yeah, exactly. So are you using JBang in your projects?
Sometimes I actually.
No, I mean not sometimes. Is kcktl, Modetect, or are you using?
So Larry is actually available via JBang, so you can do JBang Larry and then.
Yeah, but you are not using Larry. What I so is like.
Yeah, no, I'm not using JBang myself. To be honest, I don't have the need for it, but it's a cool project. I would say.
We can cut it out, so not to make.
I think Max can survive it.
Yeah, Max angry. Okay, very good. So we have a Modetect. This is the Modetect. This is like a circular project.
Yes. Well, so the Modetect. So that's the original project, as you say. So that's the starting point. That's essentially some tooling for the Java module system. So for instance, you can use it to build JLink images for your application.
Okay.
You can also use it to add or to compile module descriptors. So if you ever built or assembled a module descriptor, you, for instance, will know you need to specify all the exported packages, all the public packages, right? And what you can do with this Modetect, and it's a Maven plugin, by the way, or there's also a Cradle task. You can use then, for instance, wildcards. So you can say, I want to export everything which is not under internal wildcard. So everything but internal. And this would be a single command. And it will also help you, for instance, to specify your requires clauses based on your project dependencies. So it helps you. It's some guided authoring of the module descriptor, I would say. Earlier this year with Nikolai Parlok, I built something what we called application images. So it is JLink images, but then you don't need to modularize your application. So that's something people sometimes believe. In order to use the JLink images, that you would have to fully modularize your application, but that's actually not true. What you can do is you can, build a JLink image just listing the JDK modules which you would like to include. And then you can run on top of that on the class path, you can run your application. So that's again something which Modetect, the Maven plugin, supports. So you just tell what are my plugins or what are my JDK modules I would like to add, and then it will bundle the application, with the JLink image, and it will add your own application jars to the class path.
So this is useful if you would like to create CLI clients without Quarkus, right?
For instance, right, or if you have any application you would distribute to users without requiring a full JDK, you just want to ship a small subset of the JDK modules which you actually need, then you could use it.
But if you have Quarkus, it wouldn't make a lot of sense not to use Quarkus, right?
Yes, right. But you can combine those things, right? So you can also, of course, run a Quarkus application on such a J-linked JDK image.
No, because I'm thinking if I would like to create, something like, kcktl, I would need to have hard reasons not to use picocli on Quarkus.
Oh yeah, definitely. That's absolutely true.
Because for something trivial, yes, I see this. So let's say, my shell script could become native image, then I would just fire up, GraalVM and do it. But if I have Quarkus, then there's no downside because the Quarkus even optimizes all the dependencies.
Absolutely, so. Yes. I would always look for that. To be honest, I find myself using Quarkus for even the most trivial stuff these days because it just really, gives you this nice dev experience.
And this year, the Quarkus popularity just exploded. So many are migrating to Quarkus, and mainly
Absolutely,
because of memory and constraints and startup time. So it is nice to see that something like this became as fast popular as
they did a great job with it. Absolutely.
Okay, perfect. Any other interesting project?
Yes, there's one more what I want to mention. That's this OSS Quick Start, which also is part of the Modetect project. Or umbrella, I should say. And that essentially is a new version of a Maven Quick Start archetype. So I always had that need, I want to create a new project, maybe just build a new demo. And I always copied my existing POM files because I wanted to have the latest dependencies. I wanted to have a license plugin configured, maybe a formatting plugin configured. And that's what this OSS Quick Start archetype is doing. So it's a modern, fresh, quick start archetype, which comes with all those things, right? So it defines all the plugin versions to the latest version. It comes with the Maven license plugin. It comes with the formatting plugin. Hopefully soon there should also be a check style built in, and it can generate a module descriptor for you if that's what you want. So you have a really solid foundation for starting a new Maven project. And then there's also, for instance, GitHub action workflow already part of it. So you can push it to GitHub and it will automatically have set up CI. So that's the idea, to give you a fresh archetype for bootstrapping a new project, which adheres to, I would say, the modern best practices.
So this is to understand it correctly. So this project is a wizard, which you create, like Maven archetype, a kind of a wizard, right, which will create fresh Maven projects.
Exactly
with some useful settings, right? Like the license, GitHub integration, and
exactly right.
But it's not like what it won't generate is like the Nexus integration or whatever, where you can publish open source.
Actually, it should do that eventually. So I want to make this more powerful, and it should you give some options during the generation process. And yes, there should be an option which then configures all that release related configuration, as you say, like the Nexus staging plugin, and I don't know, maybe JReleaser from NRES. So you have that set up and all this. All the plugins you need for pushing a release to Maven Central. So this definitely should be part of it. It's not yet, but it should be part of it eventually.
So we covered all your paths, right?
Yes, all the current ones, let's say.
All the current ones, which is actually really great. And I would check the kcktl. So this is what I can use right now first.
Okay, cool.
And it already sounds great. So I can imagine how it works. And yeah.
Yeah, and so right now you would have to get the kcktl binary from GitHub, so you can go to the releases of the project. But as I said, hopefully, maybe even next week, we will already have it on SDKman, and then you can install it over SDK.
Are you also support or releasing the superjar version?
For kcktl? No.
Yes.
So right now we just publish the native binaries. That's all.
This is maybe a mistake because there is a competitor to Quarkus called Hedidon, and they had also a CLI, and they just released the binary. And I thought, okay, what's going on? Is this like, Go library or whatever? And this was, of course, GraalVM, JLink stuff. And what I searched for was the superjar first, because I would say just offer. I mean, you can just do this, right? Just offer this as
it wouldn't be a problem at all.
Uberjar. This is what I would start with because it runs everywhere, Then you have to search for the right binary for ARM, Intel, or whatever.
Yeah, we could do that. I mean, yes, as you say, so we don't publish ARM binaries right now because you cannot easily build them on GitHub Actions. So yes, we could publish the Java version.
You don't have, you say, okay, it's also available with a link, and
Exactly.
But this is super easy with Quarkus. Yeah. Okay, thank you. So it was nice to sync with you.
Absolutely, anytime. So yeah, quite a few things going on.
Bye.
Thank you. Bye-bye. See you.